a couple of you had questions about this question, so here, I'll work it for you and then we can talk about it more. So the H3 plus ion has been observed, but its structure has been the subject of some controversy. Prepare an MO diagram for H3 plus, assuming a cyclic structure. So I've drawn a sort of Lewis structure version of the cyclic structure here. So we've got the 3 hydrogen atoms that are part of an equilateral triangle, and we have a total of 2 electrons there. Now let's think about this in terms of an MO picture. We don't have a center atom, so instead we're just going to imagine the group of 3 hydrogen atoms. I'm going to assign this to the D3H point group. And so I'm going to develop a representation based on the operations in D3H. That's going to be E, 2C3, 3C2, sigma H, 2 S3s, and 3 sigma Vs. Okay, so then for our reducible representation, I'm going to imagine s orbitals on each of the 3 hydrogen atoms, and I'm going to think about which ones remain unchanged as we do each of the operations. So for the identity operation, 3 orbitals will remain unchanged. If we do a C3, all of them will move. A C2, one of them will remain unchanged. Sigma H will slice through all 3. An S3, so we'll rotate a third and then reflect, they'll all move, and sigma V will slice through one of them, so that we'll have a 1 there. All right, and so if we reduce this representation, we're going to get an A1 prime and an E prime. And so you could see that the A1 prime is going to be 1, 1, 1, 1, 1, 1. And the E prime will be 2, -1, 0, 2, -1, 0. And so we can see that if we add those up, we'll get our reducible representation. Now, let's think about what these orbitals look like. So if we're imagining the s orbitals on hydrogen in our triangle, so we have our 3 s orbitals, and our question is, are they shaded or are they unshaded? So for the A1 combination, to get the picture, we can sort of imagine what another A1 prime orbital might be. So that might be something like, imagine there's an s orbital in the middle. In that case, in order to match up the orbital on the outside with the orbital sort of in the middle, if there was an orbital there, we would want all of these orbitals to be equally shaded. They could be shaded or unshaded. Okay, so our A prime orbital is going to look like this triangle where all 3 of them are shaded. So we'll call that, this is our A1 prime orbital. We're going to have 2 E prime orbitals, because remember the E tells us that we have a degenerate group of 2 representations. And so we're going to think about what orbitals also have the symmetry of E prime. So in that case, we could imagine the PX and py orbitals, if we imagine this, so z is coming out at us, and so this is the xy plane. Okay, and so then in that case, if we start with the px orbital, we'd see that one of these needs to be shaded to overlap with this shaded lobe, and one of them needs to be unshaded, but the one up at the top will overlap equally with shaded and unshaded parts, so there will be a node there, and this one just goes away. So our group orbital will look something like this, where we have this H, H, and then H in the middle. Okay. The other EG orbital will, the other E prime orbital will overlap with this other P orbital, so we'll have a shaded lobe here and then unshaded lobes at the bottom. So overall, that P orbital will look like this. We have our triangle, and each of our H's, H, H, and H. So we know what our orbitals look like now. We know that our molecular orbital diagram is really just going to have these 2 orbitals. So if we think about where they would be in energy, the A1 prime orbital is going to be lower because it's a bonding orbital. We have electron density between all 3 atoms. The E prime orbitals are going to be degenerate, and they're going to be higher in energy because they have a node between the atoms. So that will make them slightly anti-bonding. So you see those nodes. And so if we imagine filling in our 2 electrons, they would both go in the A1 prime molecular orbital for an overall bond order of 1. So here you see that we have 1 bond that's spread over 3 atoms, and so you can imagine that while this might be possible, we just don't have a whole lot of electron density shared among those 3 atoms. But so here's how we draw the molecular orbital diagram of this cyclic structure that has no center atom.